Alright, today we're looking at FRQ number 8. The same rules apply as always. Alright, so what we're doing is we're given this Maclaurin series. It actually gives it straight out to us. And it says that it converges to f of x as long as x is within the radius of convergence, which makes sense. So the first thing it asks us to do is use the ratio test to find the radius of convergence. Pretty easy. We're going to do the limit as n approaches infinity of an plus 1 over an. Okay, so that's the limit as n approaches infinity of an plus 1 is going to be negative 3 to the n over n plus 1 times x to the n plus 1 times an, which would be, or divided by an, so we're going to do times the reciprocal of an, which would be n over negative 3 to the n minus 1 x to the n. There's our thing, and now we're going to multiply and simplify. So the n and n plus 1, those are going to stay exactly the same. All right, so we're going to have n over n plus 1. The x to the n and x to the n plus 1, those are going to simplify, and we're just going to end up with x. And the negative 3 to the n and negative 3 to the n minus 1, those are going to simplify, and we're going to end up with actually a negative 3 to the positive 1. So we end up with negative 3. So this is our limit. Now, when we do the limit as n goes to infinity, we have common powers here and here, so we can just look at the leading coefficient, which is negative 3. So we have absolute value of negative 3x is our limit. Now, to make this a convergent series, we'd need this to be less than 1. So we have negative 3x, absolute value is less than 1. So 3 absolute value of x is less than 1. Absolute value of x is less than 1/3. So, because it says absolute value of x is less than r, this is our radius of convergence, which means this is our radius of convergence. So r equals 1/3. Easy enough. Let's look at the points. You get 1 point for setting up the ratio. You get 1 point for computing the limit properly. So this part right here. And you get 1 point for the radius of convergence. Right there. All right. Moving on to part B. Write the first 4 non-zero terms in the Maclaurin series for f prime, the derivative of f. Express f prime as a rational function for x less than r. Now, what you should immediately be thinking when it says express f prime as a rational function is that we only have a couple ways to do this. We could either use sine, cosine, e to the x, those 3 functions that we absolutely know, or we can use a geometric series. So after we take the derivative, we need to look, is this going to be equal to sine, cosine, e to the x, or is this going to be equal to a geometric series? So let's start by taking the derivative. We'll just take the derivative of every term, and it really only asks for the first 4 non-zero terms. So the derivative of x, is 1. Derivative of x, or 3 halves x squared, negative 3 halves x squared, is negative 3x. Derivative of 3x cubed is 9x squared. The next term here, we don't have it up there, so that's when you plug in 1, so you plug in 2, no, maybe, yeah, you plug in 2, that's when you plug in 3, so we know what we get when we plug in 4, so that would be x to the 4th, negative 3 cubed over 4, so negative 27 over 4. So we end up with negative 27x cubed. And that's our next number there. So those are the first 4 terms. So it covers this first part, right? The first 4 non-zero terms for f prime of x. Now we need to express this as a rational function. So the first question, is this sine, cosine, tangent, or e to the x? And that's no, because it has every single term, and it alternates, and it doesn't have any factorials. So it definitely can't be one of those. The second question is, could this instead be a geometric series? Because what we can use is, if it's a geometric series, we can use the geometric shortcut. Well, let's see. Is there a common ratio between each of the terms? Negative 3x divided by 1 is negative 3x. 9x squared divided by negative 3x, well, that's also negative 3x. Negative 27x cubed divided by 9x squared, that's also negative 3x. So there is a common ratio. This is a geometric series. That means f prime of x is equal to the initial value, 1, over 1 minus our common ratio. So we get 1 over 1 plus 3x. There's our derivative as a function. So you get 2 points for the first 4 non-zero terms. So just to point out, that's an easy 5 points on this problem. 3 for the ratio test, 2 for writing the first 4 terms. And then you get 1 point for the correct function. Lastly is part C. This one is not hard, but it is tedious. Okay? It is tedious. So, first it wants us to write the first 4 non-zero terms for the Maclaurin series for e to the x. That should be super quick for us. E to the x is approximately 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Super quick. All right? And that should be approximately not equal. Use the Maclaurin series for e to the x to write the third degree Taylor polynomial for e to the x times f of x. Now, it doesn't just want us to multiply e to the x times f of x. It wants it as a polynomial. And it wants it as a third degree. So what we're going to do, we're going to say e to the x times f of x is approximately e to the x's Taylor polynomial, but only to the third degree. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial times f of x's polynomial. So x minus 3/2 x squared plus 3x cubed. This is where this problem gets frustrating. So I'm actually going to give me some more room, as much room as possible. So we're actually going to have to multiply out these two polynomials. Andrew Ziegenhorn, you're going to be so happy. So we're actually going to multiply these. 1 times x gives us x. 1 times negative 3x squared gives us negative, I don't know why I started right in the middle. So we have x, negative 3/2 x squared, plus 3x cubed. Now, here's the secret to make this problem easier. If you look back at the instructions, this tells us it only wants the third degree Taylor polynomial. So as we multiply these, if we ever get a degree that is bigger than 3, we can just not write that. Okay? And the reason I say that is because we will see that here. X times x gives us x squared. X times negative 3/2 x squared gives us negative 3/2 x cubed. X times 3x cubed gives us 3x to the 4th. That's bigger than a degree of 3. We don't have to write that one. So we finish that one. X squared over 2 times x gives us x cubed over 2. 2 factorial just becomes 2. x squared over 2 factorial times negative 3 halves x squared. That gives us a degree bigger than 3. We don't have to write that one. Then we have x cubed over 3 factorial, which is the same as saying x cubed over 6, times x, once again, gives us a degree bigger than 4 or bigger than 3. We don't have to write that one. So here's our polynomial. Now we need to combine some like terms. So we have x. We don't have any more x's. Negative 3 halves x squared, positive x squared. Those are going to combine. So this is 2 over 2, negative 3 over 2. We get negative 1 over 2 x squared. Then we have 3x cubed, negative 3 half x cubed, 1 half x cubed. Negative 3 half plus 1 half gives us a negative 1x cubed. Negative 1x cubed plus 3x cubed gives us 2x cubed. So the third degree Taylor polynomial for g of x about x equals 0 is this right here. You get 3 points on this problem. One of them super easy. One of them is just making sure you got that part. The other 2 are making sure you multiplied this out properly. The problem with this one is people try and multiply out every single thing, and it makes a mess. What is always easier is just to plug in and go. Okay? All right. If there are any questions, make sure you ask. Y'all have a great day.